Hey everybody, in this video we're going to walk through how to implement a simple singly linked list using Python. So what we're going to try to do is we're going to try to build a linked list that looks like this. So we have 3 nodes and they just contain integer data, so let's choose 15, 20, and 35. 15 is going to be our head of our linked list, and then these are the next pointers between nodes. Our last node will always point at none. So let's take this conceptual model and let's turn it into code. So we're going to open a basic Python file in REPL, which is an easy to use in-browser IDE. The first thing we're going to do is we want to create a class to represent a linked list node and kind of wrap our data and next pointer together. So what we're going to do is declare a class called node and then set up its constructor or its init method in Python. And we're going to pass in a data parameter because that's going to be set on initialization, and we're going to create one property called data and assign it to the value that's getting passed in. And then we're going to also create another property called next. So this is what will point to the next node in the sequence. And we're always going to initialize it with none because when we first create a node, it's not going to be hooked up to our linked list yet. So now that we've created a node class, which is kind of like a blueprint for our node, we're going to go ahead and create some nodes or instantiate some node objects in memory. So I'm just going to give these some just simple variable names, and I'm going to create the node with passing in the integer data, a lot like our initial drawing. And I'm just going to create 3 nodes and then assign them to variables so I can use them later. When we create our nodes, we're going to also think about how are we going to hook these nodes up and arrange them. So now we have 3 nodes that exist in memory. They have no connection to each other. So right now you could kind of think of them as sort of sitting in memory somewhere with no links between them. So what we need to do is we need to take these objects that are sitting in memory and link them together. So the way that we can do that is through variable assignment. But before I start linking them together, one of the most important things that we need to establish when we're creating a linked list is our head pointer. So we can just go ahead and create a variable called head and assign it the value of the new node, or of the first node that we want to point to. So in this case, 15. So once we do that, the head is what's going to give us access to the rest of the linked list. So right now we're creating separate variables for each node as sort of an example to illustrate what's happening. But in the future, we're going to create nodes more dynamically, and we're not necessarily going to have access to all of these variables. It would be very cumbersome. So imagine you have like 1,000 nodes in your linked list. So the only node we really will have access to is the head. Sometimes we might also have something that called the tail, which points to the last node, but we don't have any sort of arbitrary access to the middle nodes like we would in an array, because we don't know the location or address of those objects in physical memory. So now let's think about how we can link nodes together. So we created our head node, but how do we basically create these links in Python? So the way we do that is through variable assignment. And if we say how do we link these together sort of in English words, we can think about taking the node that contains the data 15 and setting its next pointer to the node that contains the data 20. So we can go ahead and grab these variables, grab our first node, which is our head as well, access its next property, and then assign it to the next node we want in the sequence. So now next is no longer none for node 1. It's now pointing at node 2. And so how do we hook up node 2 to node 3? So why don't you go ahead and pause the video, think a little bit, think about doing it on your own. Right, so how we assign our point node 2 to point to node 3 is we can grab node 2's next pointer and then point it to node 3. So now what we've essentially done is we've created these nodes in memory and we've also hooked them together. So we've made the next pointer point to the next node in the sequence. So we have a complete linked list living in memory. So let's say we want to print out all the items in our linked list. And we're going to imagine that we don't have access to these separate nodes. So this is just sort of to illustrate what's happening in physical memory. But a lot of times we only have access to the head of the linked list. So given an arbitrarily long linked list, how can we print out all the nodes or visit all the nodes, or this is what's commonly called a traversal. So if we think about it and we only have access to the head, some people might be tempted to be like, oh, we could just move the head and then visit each node. And you can do that. However, if you want to use your linked list later, you have completely lost access to the first node. It will be dereferenced and garbage collected. So we don't actually want to modify the head. But a common pattern that you'll see with any sort of traversal of data structures like this, like a linked list, is what we'll do is called create a temporary variable. And so this variable often is called like temp. A more common name for it would be current, because it's referring to the current node that we are looking at. And what we're going to do is we're going to move current to look at each node one by one. So like in our scavenger hunt analogy, we can only look at a location one at a time, and we can only move to the next location via the next clue. So the way that we move our current variable, or often we call it our current pointer, is through variable reassignment. So a lot of implementing linked lists has to do with reassigning variables and keeping track of what node we're looking at. Another thing we're going to use to implement this sort of traversal is we'll notice that we're kind of doing the same operation or the same behavior over and over again. We're looking at the current node, we're going to move it via reassignment, look at the current node, move it via reassignment. And when we want to do a bunch of repeated tasks in most programming languages, we use something called a loop. In this case, I want to keep moving my current variable until I basically hit the end of the list. And how that translates more specifically into code is that I want to keep moving until my current points at none. So this is a good use case for a while loop, because we can keep repeating a step while our current is not none. So let's translate this into code now. So we're going to go ahead and we're going to assign our current variable to the head. So we declare a variable called current, and then the first node we want to look at is the head. So we're going to go ahead and assign it. And then, like I said before, we're going to create a while loop. We're going to say while the current is not none, we're going to keep repeating. So what's going to happen is I'm first just going to print out what's there. Just want to see what's there, so I can just print out the data. If I print out the current variable, I'll get some sort of cryptic looking thing with like node and then some kind of address. So that's printing out the object, but we want to actually just print out the integer data. So that's why I'm doing that. And then this is really the key to moving through the linked list. So we're going to take our current and then we're going to reassign it to current.next. And this may look a little weird, but what's happening here is we're saying update current with the next node in the sequence, or reassign current with the next node in the sequence. So what's going to happen is we'll stop this loop once current is pointing to none and it's reached the end of the linked list, and we'll keep moving and reassigning so that we can achieve visiting each node one by one and then printing it out. So if I run this, what I expect to see is I expect to see 15, 20, and 35. So let's see if I get what I expect. So 15, 20, and 35. And this piece of code will work for any arbitrary length linked list as long as we have access to the head. So to recap, what we talked about was we talked about creating the basic unit of a linked list, a node, in class form. We instantiated 3 nodes in memory. We created a head variable to point at the first node, and then we used variable assignment to hook the nodes up or establish those links. And then finally, we talked about how we can traverse using just the head. So this is the basic groundwork for a linked list. And the next lesson, we're going to talk about how we can create nodes and essentially append them or prepend them or insert them dynamically without having to do this hard-coded, creating a bunch of separate nodes and separate variables. We'll also talk about wrapping all of this in a linked list class that uses composition with these nodes. So thank you very much for your time. I hope you enjoyed learning about linked lists.